C# 13 with Dustin Campbell.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a full-service software architecture and engineering firm that serves companies using .NET and Azure and everything Microsoft. Essentially, we build mission-critical software systems, rescue failing projects, always empowering software delivery with a proven approach. I am excited to announce that my latest book is now fully released. The book is about software leadership. It's called The 5 Pillars: Leadership for Effective Custom Software. And the book is really for anyone who's attempting to make a custom software team highly effective. And so if you want your team to deliver world-class results, this book could be for you. Teams are also doing book studies, and which are really team studies, doing team discussions around it. I'm excited about that. And so if you, dear listener, would like a complimentary electronic copy of the book or the study guide, then just send me an email and be happy to get it to you. That's jeffrey@clearmeasure.com. And for those of you who are in a lead architect or software executive role, you might want to join our monthly forums. These are interactive, deeply technical sessions that I really enjoy facilitating. It's a group of really, really smart peers. You can sign up on clearmeasure.com. And I've also just launched a new lead engineer live stream on the YouTube channel, youtube.com/clearmeasure. And for any software engineers looking to be successful in an engineering lead role in a software project, I cover just topics essential for that and answer questions. So you can see that on the ClearMeasure YouTube channel. And I want to welcome to the show a guest that I wish that I'd had on a long time ago, Dustin Campbell. He is a principal software engineer at Microsoft. He works on enhancing .NET tooling and contributing to the design of the next version of C# as part of the language design team. And prior to that role, he spent several years working as a program manager on Project Roslyn inside Visual Studio, and he also contributed in a strong way to the Razor UI framework. And he recently presented a session at .NET Conf 2024 on what's new in C# 13. So, Dustin, welcome to the show. How are you, sir?
Thank you, Jeffrey. I'm doing great. I'm very happy to be here.
Awesome. Yeah, you work really well with Mats Torgerson, who has been on the podcast quite a bit in the past. I want to kind of pick your brain on C# and the latest version, where it's going. But kind of before that, just for the listeners who maybe haven't seen you speak or didn't attend the .NET Conf conference or whatnot, kind of back up. What are maybe a turning point in your career? How did you end up literally on the C# language team that all the .NET programmers use?
I mean, I can go back really far. It's very weird, right? Because I didn't go to school for this. I have a jazz guitar performance degree from Bowling Green State University in Ohio.
Nice.
And so when I I was always into computers, but when I kind of had this very strange sequence of events that got me through a component vendor named DevExpress, working on IDE tooling, and then landed at Microsoft now, 16 years ago. And it's just over time, just kind of, I was a C# MVP. I got very close to the language, and it was just this wonderful kind of happenstance. I mean, it's not like something you go and say, I would like to go in the C# team, and that's my career path.
Mm-hmm.
It's just like a lot of just kind of strange, lucky events that landed me where I'm at. And I feel very, very fortunate to be here. It's a lot of fun. It's only a shade of what I do. Everybody on the C# language design team they're not just the C# language design team, except for Mads Torgerson, who that's what he does is be the language architect. Everybody else is doing lots of other things, and we participate in the language design team, generally, an average of like 4 hours a week. But it's exciting and it's fun. But I never thought I'd get here. It's kind of weird.
Yeah. Well, it's so central to everything. We think of .NET, the core libraries and Visual Studio and the compiler. But then, okay, we as programmers, besides English, have learned this English derivative code language called C sharp. It's not C++. It's C sharp, but everybody uses it.
Yeah, and I like, C sharp for me just fits in this kind of like really nice space of being, having the ability to do very, very highly complicated things, getting very as low level as I need to, within a garbage collected, kind of language like this, but also having very high level concepts and really rich libraries. And so, it's kind of this wonderful confluence of, things that I've worked in. Like, I was, I came up as a Delphi developer for Borland,
Mm-hmm.
And I went via C++ and little things here and there in Visual Basic, and C sharp is just the language that kind of, I don't know, it spoke to me. And you really bring up a good point. It's like, oh, other than kind of the natural language that we might speak, code is like this other language that we use to express ourselves. And so when I think of the value of C sharp and how we think about it in language design, it's not just about like, yes, we want to enable certain scenarios, but we also want to make it like pleasant and natural for somebody to just be able to express themselves. Here's what I would like this program to do, without being too fuzzy, but also not being too specific unless I want to be. And it's kind of an interesting sort of space to be in with programming language design. I think C sharp has done a great job over the years.
Yeah. Yeah. I don't want to ask you about what is in C Sharp 13, because any of the listeners can go and just kind of look that up. And of course, you gave a fantastic presentation that's on the .NET YouTube channel just a few months ago at the time of this recording. And there's, a good amount of features where you look back and like, oh yeah, it's curious that C Sharp didn't have that feature, like simplification features. Partial classes have been around for a long time, and now we have partial properties and indexers. It's like various things like, oh, you know what? Maybe that is a gap. Let's fill it in. It's a nice to have. It kind of simplifies some code and workarounds. But in either the last version or the last couple versions, are there any features where you think it's like, okay, no, this is a big jump forward as opposed to a nice to have, a simplification?
I look at, and I've talked about this before in certain space, but the idea that certain versions of the language will change what we mean by modern C sharp, right? Sometimes, there's just a handful of features. Maybe we enabled some features for the libraries team, or you just bring up something like partial properties. Well, we could have done that a long time ago, but the scenarios weren't strong until something like source generators had come along, and source generator authors wanted ways that when their source generator is generating code, that they can have a partial class that the user can then, introduce their own bits and control the behavior of that source generator. So the scenarios start to come up. You start to build those kinds of things. But to me, it's those features, those versions of the language where you learn a new way to express yourself. I think back to like C sharp 6 was where we introduced expression bodied members, where you didn't have to use the curly braces for when there was just one statement or one expression. You could just use an arrow and everything looks like lambda. But once people started doing that, programs started to look different. C sharp started looking different. But it didn't really have any impact on any of these libraries. It's more about your expressiveness, how much boilerplate you had to write. And so like, I really like in, recent releases, you asked that question. I mean, I think in C sharp 12, I think was the collection expressions feature where you could just do the square brackets and just put, elements in there. And depending on the type of what it's being passed to, we will either generate the right, a type that, especially if it's an interface, will generate a type for you, or pick a good type or something that's efficient. Or we'll just, if we can construct that type, we will. But yeah, collection expressions was the feature to me that now feels like, well, that's modern C sharp. Like if I see a code and I'm like, wait, you need up an array? Come on now. Like that's C sharp 1.0,
Yeah.
like, and C sharp 12 is like, well, no, there's collection expressions. And then what I especially like about that feature is that it then improves for me, it improves maintenance, right? If I use a collection expression everywhere and then I decide, you know what, I need to change that list of t to, I enumerable of t, I can just change it and I don't have to go update every place that called it, that thing. If it took a list of t, we just now recompile it and it will put in something different that will match that type. I think that's cool. I think it's a super cool feature.
Mm-hmm.
So.
Yeah. Well, I'm thinking what made C# look different. Async and await certainly made a lot of C# look different to me.
Yes.
The question is, some number of years from now, when it's labeled all over the place, will we say, the guidance has been to label methods with that word, but now the word's everywhere. Is that now normal? Do we just stop naming methods with that word?
I don't know. It depends, right? That feature is interesting in particular because it harkens back to when C# has done something that everyone else copied, right? Now async await as even as a pair of keywords or as just an await keyword appear in so many languages to mean that because it was a good abstraction. It was a good way of expressing that. Like before async await, to do these things, to write that raw task parallel library code or raw multi-threaded code and not have the abstractions that we could build around it with async await, it was painful. As far as whether we name the methods different, I don't know. Sometimes we have, like part of the reason why it is, name it async, put an async suffix on a member name is because it, it's just an indicator when I'm trying to write the code. Oh yeah, I need to use that await thing. I didn't forget that. Because when you forget it, it comes out as a task or whatever awaitable thing, and it flows through. Maybe you have var on the left and you're like, I have no idea what's going on right now. I've got an error way further in my program and I have no idea why. And also because, sometimes you have an async version of an API and a non-async version. So it can be a nice discriminator. Yeah, I don't know. It's convention though. It's not like I'm going through and all of my tests when I have, XUnit tests and they return a task because they're async. It's not like I'm naming them all with async, so it depends.
Yeah, that too. The test is one where, the convention hasn't really caught on there.
No, and I don't think it should because it's when you name something async, I think this with the suffix, you're trying to say to the user of that, the caller of that, here, this is an async thing. Do something. You need to do something differently to call this.
Yeah.
Right. But with a test, I don't call those. That's for the test framework to call. And so that's just extra. So I'm always, global suppressions, just suppress that that suggestion.
Yeah, each test is an entry point into execution.
Yeah.
Essentially.
Yeah, exactly. It's like a new main method.
Yeah. So. Right. Awesome. Well, one question, because it's impacting everything, just like just like all the link features, way back when they kind of changed a whole lot. And I want to ask you, just kind of going forward, a question that, various people have been asking me. Here's the small question. .NET 9, .NET 8, .NET 9, short-term support, long-term support, but what do people need to do to take advantage of C# 13, but maybe they want to stay on .NET 8? Can they do that?
Yeah, you can do that. I think one of the bits about they can kind of sort of do that, right? Like one of the problems we have today is that we've tied everything, like there's a confusion that that you have to tie and use, like if I'm using the .NET SDK for version 9, that I have to be targeting .NET 9, and that's not the case, right? I can say, it's all about the target framework for my project, and I can say no, it's .NET 8.0, and I'm using the latest SDK because that's more of like tooling, right? It's like in a way, it's like if I install a new Visual Studio, but I'm still targeting some old thing, I can still continue to target that old thing. The thing with the languages though is that so many times, or so much, for years we would have like types that were necessary, that were part of the libraries, part of the core libraries of whatever version of .NET. Link is a great example of that, where it was .NET Framework 3.5 that you would use for C# 3, and that would have all of the extension methods and the func, like all the func in action, all that sort of thing that was there that we would use for link. And then that continues to a degree, right? We try very hard to make sure that you can sometimes write, you know, if those types aren't in the libraries, if you bring your own along, if it's got the right shape, the compiler will try and use it. We try not to tie it too directly from that perspective. So, so long as you're not like exposing them in public APIs, maybe you can, and you're targeting, like, say, an early version of .NET, you could be like, well, sure, I can declare my own system.range and my own system.index types, and it'll work. But that's with library types. But also today with .NET, we're adding features to C# sometimes that require runtime support, and they require that you do have to use a new .NET runtime. And we actually have a check where if you're compiling and the runtime, or you run it and the runtime doesn't support a feature, we'll not allow it to happen, because we need that to be there. We've done a lot of work to kind of flesh that through the whole system, not just the libraries, but also the runtime itself. And so sometimes you run into that sort of thing. So in general, we tend to recommend that if you're targeting a version that's lower, that it's a better idea to use, like, from a perspective of not getting yourself into trouble, of using the same language version that would have matched that. But you can technically do it. It's just you wind up in a place where you have a language might have some features that don't quite work. You have to do extra work to make that work, and that's it. So we don't recommend it for like everybody. It's not exactly a supported scenario, but you could totally make that kind of work. I remember Scott Cate had a talk years ago that was all about, like, it was called Hacking the C# Compiler. And it was all about, like, well, here's how you define your own extension attribute and all of these different, we call polyfill your own types that the language cares about. And you could do all of this, link stuff on C# 2, for example. And it was like an extension methods and things like that. Still totally do most of that.
Yeah. Oh, there's so many features that have cropped up over the years. It takes the intentional study to actually just be familiar with all of them.
Yeah. And in some cases, we have to do that, right? Like if you go to the Roslyn repo or even the Razor repo, we've added our own, like, system.range and system.index is a good example. We've added our own copies of those types, because in that world, we're actually, building stuff for Visual Studio, which still runs on .NET Framework. But we also want to dog food our own language features. So we will sometimes polyfill, as we call it, polyfill some of those types so that the compiler will be happy. We can use a newer version of the language, but we go into it knowing exactly kind of how I guess we call it a decoder ring of what sort of language version that doesn't really exist. It's like a collection of this base C# version plus this set of features. That should work just fine if you do that. So we actually do that ourselves sometimes. But yeah, I can't come in and say, I recommend you do that. I would not.
Right. One other feature that has had a lot of people talking about it, a number of versions back now, is records, versus class and whatnot. And I don't know if the dust has settled, but in your opinion, there were people saying, oh, should we use them for data transfer objects? I use them for things that are going to be serialized over JSON, over a wire, for a message queue, or should every class that's mapped with Entity Framework to a database, should those be records? And you're like, has the dust settled on enough people experimenting where, yeah, you know what, you used to do this, and now in those scenarios, it probably makes sense for them to be a record class?
It depends. A lot of times, I use them for a lot of data, but it's often when I care about things to be what we call value equatable, right? Where they're considered to be, like if I've got somebody's name and it's got the first and last name in there, and I've got another object with the same first and last name, even though they're different chunks of memory, like they're reference types, but if they're different in different chunks of memory, but because the values that make them up the same names, they compare as equal. if I care about value equality like that, then it's always a record, because doing that otherwise is painful.
Mm-hmm.
But records is a feature that was kind of it's sort of a good example of a feature where we actually continued to build that feature and fill out various scenarios over several releases, 3 releases, I think. I think they came out initially in like C#8, like a first version that was only classes, and then we added like record structs, which have some interesting semantics. We added in addition to that, we added like required properties, which is really a feature for records to say that when I'm constructing a record and I use these init only properties with them, then I want to be able to say, well, some of these are required. Whenever you construct it, these have to be set.
Mm-hmm.
And some of those kind of came out of the whole record scenario. When we started records, a goal was to try and break it down into little features like we did with link years ago. Link is this wonderful feature because there's this query expression syntax that almost nobody uses anymore. It seems like I never see it, but all the features that were added to build that query expression syntax. And when I say query expression, I mean like the from x in or from p in point select, p.x times
with spaces instead
p
of dots.
Y. Yeah. But then, in order to support that feature, we added extension methods and lambda expressions and type inference and anonymous types and all those kinds of things that were in themselves like discrete, useful, general features. And so we kind of started records with that idea, and that's how we get init only properties that can be used anywhere. We're like, well, we need this for records, and we've added some features here and there like that for records. But and so it's kind of that one is kind of an interesting story. I think that Dust has settled at this point. It took 3 major versions, but there's still some scenarios that at least record syntax might play into. But as a feature, I think the Dust has settled. If you feel like that's the right tool for the job, I'd say go for it. But just bear in mind that they are different from doing up a class, right?
Mm-hmm.
Where it's like, well, the equality, we've done the work to handle the equality for you, and we did it in a particular way, and it's not deep equality, right? So very often when I'm making records, I find myself having to override equals and get hash codes because I've decided, well, one of these is an array, and I'm like, but I need to go through and I need to do like a dot sequence equal on the array because I want the deep equality. And so sometimes that comes up, but in general, yeah, I mean, especially for these simple kinds of like database record objects, sure, makes sense to me.
Yeah, nice. Well, if I could, you're always thinking about the future, and not just C#14 or hey, maybe what might we do next, but I want to get your view on what the conversations in the C# team have been around GPT AI. And out there's been a lot of people saying, "Oh, you have to become a prompt engineer. You have to figure out, well, I'll just say a specific type of language to now interact with a new technology." How do you think about that? When okay, well, there is some new way to craft something for this new technology. And now we've got deterministic C#. What have kind of been your own thoughts on there?
My thoughts on AI and generative AIs in particular, when it relates to development, is less about like, okay, it's not deterministic, or I have to use a chat and prepare a prompt to get the prompt just right and all that. For me, what I want from that technology is often about productivity and tooling, right? So I love the, GitHub Copilot completions that like do the next gray line of text, because so often it's right. It's what I was thinking next because it's got the context of everything I've done here so far.
Yeah.
And I want to, and it just helps me just keep on going and going faster. And so anything that can help me code to a degree that's like, oh, it's just magic that's going faster. I mean, for years that was IntelliSense, right? Which wasn't necessarily predictive. It was just you press dot or you typed a character, and actually at first it was only on dot.
Yeah.
And then in Visual Studio 2005, we made it pop up on the start of any identifier character. And it was like, okay, well, we're going to show everything here that's whenever you typed a letter. And it was, we've continued to kind of adjust that. Well, now it's like, well, we're going to predict. And, with the next line of code. And to me, that's just about productivity. It's just about being faster and trying to give me ways of using generative AIs without me having to go down and write a prompt, because to me that's disruptive to my inner loop, my dev workflow,
Mm-hmm.
right? When I'm in code, there's a lot of things. There are times when I want to use a chat. Maybe I'm doing deep research. Maybe I'm actually exploring something. I'm trying to learn something. That's fine. I don't mind using a chat for those kinds of activities. But when it comes to code, I just want it to be, just helping me be as productive as possible. And so I've been thinking a lot lately about, especially in this whole new kind of thinking about like, well, how can AI agents help us in developer tasks? And thinking a lot about like, well, what are the things I don't want to do? As a developer, I hate doing this, and figuring out like, well, can we figure out, more, what we would call an agentic workflow to kind of build up some tools that could be, the LLM could help invoke, so that we can have, essentially things I don't have to do, and
Mm-hmm.
I don't have to like go and mess around with anymore. It'd be amazing if I didn't have to go find repros from bugs that were filed that didn't have clear repros, but instead some agent has already sorted out and tried it out and tried to figure out based on several, bugs that have come in that look related, and figured out, well, actually this, from the screenshots and everything, here's a repro that might work, and
Mm-hmm.
gets me to the line of code, right? When I'm debugging, like that sort of thing would be just wonderful. And so, I've been thinking a lot about those sorts of, kinds of uses of AI where it's not just me walking up to a chat window. I think that's, I don't know, it's cool. It's kind of basic too. So
Yeah. Well,
yeah.
one of those basic things that I don't like doing, I don't like any of my engineers to do, but somebody still has to do it, is just the regular boilerplate saving data through Entity Framework to a SQL Server
Mm-hmm.
database, and even longstanding existing software projects where the patterns are all there. You kind of picked your way to do it. You have whatever layers that you have in that particular application. And then something comes along, it's like, ooh, you know what? We need another one to many. Therefore,
Yeah.
guess what? I'm going to add a table to the database. And guess what? I have a new class, and I have a new mapping, and I have a new integration test in my test suite. And I have this. And it's like, I've got this list of stuff. It's like, yeah, I know what I got to do, but we just got to do it. And yeah, if there was an agent in Visual Studio that kind of knew the
Absolutely.
patterns, like, and go give me another one, go. That would be
I
awesome.
mean, if I had a visual tool, I mean, we called it Visual Studio, and I'm just spitballing here, right? I'm not building this right now, I'm not aware of it. But like, if I had an old school visual tool for, visualizing my database, we used to have tools that would generate your schema and try and update your code, and it
Didn't kind of pan
wasn't
out, did
very
it?
useful. I mean, the promise of this is that it could work. One of the things I've been thinking about a lot is that in compilers, and the space of compilers and code analysis, static analysis, especially, where we think a lot about like always being correct, and as you said earlier, deterministic, like
Mm-hmm.
that, such that it's actually really hard when we want to analyze and solve problems. They're not always correct. The
Yeah,
answers aren't always there, and we have to make a
right.
guess. Oh, forget about it. Because like that really flies in the face of something like static analysis. Is like just guesswork. But that's exactly what the LLM's great at. It's like, well, predictively, educated guess from a lot of training and a lot of sources. This could be the thing, and then coupling that then with tools that do more static things. If you were able to say, yeah, I just need a one-to-many relationship here. Sorry, we need to do some extra normalization, and then that happened for you, coupled with static analysis to make sure it was accurate when it was done. And then you're like, cool. What else do I do with my day now? I guess I do this very fast now. You'd be so productive, right? You
Well,
know?
once that flow is proven, once it could work, then even if I'm creating a brand new system, I'm still going to have to do that a few times just so that there's enough examples of the way that of the selection of patterns that I want to be there, as opposed to,
Hmm.
average patterns that happen to be on GitHub. But once I have a few examples in the system, I should just be able to give me another, and work and
Right.
just have all this code so much, it's kind of like, it's another, level of quote coding forward.
Well, exactly, because as the model continues, I mean, especially as we get to a place where we're not just walking up to a model, with a predefined set of weights up front, but we have that memory built in of what's come before, and it can pick and choose and decide things. And now we've weighted the entire thing differently so that I imagine a world where when it's suggesting code for me, it always suggests it in the way I write it,
Yeah.
or in the way that this repo looks, right? I mentioned collection expressions earlier. Maybe not everybody's using collection expressions. It might not have become part of their normal like muscle memory for what their fingers reach for.
Mm-hmm.
They might still be newing up arrays everywhere in this repo because that's what they do. So why would it suggest collection expressions?
Yeah.
Instead, it should know. Yeah, they never use that here. They use this is what they do.
Right.
And so that generative AI should be weighted and parameterized such that it comes in and it does it kind of like I describe it as like
A chameleon
it's almost
coder.
as if you walked in a chameleon coder is a really great way of putting it. It's like if you walked up to a chat GPT and it started talking back to you in your voice,
Yeah.
right? In your manner of speaking. That would be bizarro, but it seems possible with something like, especially with something like code.
Yeah. Yeah.
Yeah.
I was just,
And then I'm more productive because I'm
I,
not cleaning up after it.
I started a new solution a few weeks ago just to test out the Azure OpenAI semantic kernel. And I
Hmm.
just created a new in-unit project just to have those test entry points. And first couple of times it's given me generic stuff, just straight from GitHub. But then I added a couple of Olama versions just to run the large language model locally. And then the next time it suggested the Olama API because yeah, I'm really using Olama. I'm not using
Yeah,
GitHub.com average.
that's awesome. And
So
and I think that will continue, especially in the developer tools space, because honestly, as developers, we're going to be first on this every time. When there's like this new kind of tech,
yeah,
it's we need the developers on it so that it gets to the second order of developer applications, making these AI features more of kind of like just people's lives, giving them useful things.
yeah.
And so, I mean, yeah, I think the developer tools really need to just kind of just morph into a lot more of this kind of like just AI smarts that make you more productive. They're not here to replace your job; they're just here to enhance your job, right? And I love that.
As we kind of come to the end of the interview here, we mentioned testing a couple of times,
Hmm.
and so much about the shape of the tests is a language. You got the libraries,
Yeah.
but then you have the latest version of C# and a bunch of helper asserts and all kinds of helper libraries that make the shape of a test very different than business logic or rules, production code.
Hmm.
And so as we kind of fast forward into this era where we have some agent code or the old pattern, the gateway pattern into a dependency where we're sending this string. I'm thinking, well, we've sent strings to SQL Server for years. So we have this
Hmm.
dependency where we're sending a string and we want something back. Well, now we have to assert. Does C# need to kind of have any additional features for that world where we are asserting and interacting with this new type of dependency, a large language model, or really is it just a pattern and the C# that we have now is just as good?
It reminds me. Your question kind of reminds me of one we got a long time ago. Mads was asked like, "So when are you guys going to build like a feature for the cloud?"
Yeah,
Right?
yeah.
And Mads is like, "We did that. It's called Async." And that's kind of my similar quip. Though I think it's different. I think there's a couple of embedded questions in there, which are like, are there features that would help, you write for an LLM? for example, if I'm making API calls.
Hmm.
And those are the sorts of things where we have an active dialogue going with the libraries team, the guys working on semantic kernel and those sorts of things. Like if they can dream up a language feature that would be useful, absolutely.
Hmm.
And that would have to be something that they couldn't just feel like they're doing, in API, and like that an API wouldn't be suitable or doesn't feel natural, that they need language support. That's kind of like the next level. We're going to
Yeah.
add language support for something. And there are a couple things in the works that we've been talking about a lot. We've been talking, we talked a bit about earlier, like last year, we talked about the new extension support that we're building for C#, which is essentially just like extension methods, but more. All the, getting to more things that you could make an extension of an existing type. And things like being able to have extension operators, for example, can be very useful for the libraries teams that might be, working on some of that sort of thing. I always wonder if, we need better support, language support, if it comes up. If this becomes very commonplace, maybe we need language support for something like vector database and embeddings and those kinds of things that you would use to communicate with an AI. If libraries, if the APIs that and the facilities we have in C# for them to produce the right APIs aren't quite good enough yet.
Hmm.
I don't know. So it's a good question. We are always looking. I don't think we have anything like, haha, this is coming, Jeffrey. I got, exclusive. But it's stuff that we're still thinking about. So for what it's worth. And as far as like assertions, you mentioned that. I think actually I was thinking about assertions a little bit, at least with the Fluent assertion library, which I've used in a number of different repos.
Hmm.
And I'm like, that's really cool, but I hate writing those empty parens.
Yeah.
And
Yeah.
and that's exactly what, say, extension properties might be very useful for someday, for some sort of Fluent assertion
Right.
library where I don't have to write those.
It's just a
parens.
library. Yeah.
Yeah. And so that kind of thing might be very useful for library authors to kind of make those next set of assertions.
Nice.
Yeah.
Well, as we close up, it sounds to me, don't let me put words in your mouth, but it sounds to me as kind of someone who's on the, working in the C# area of Microsoft and kind of everything ripples out from there, that you and your colleagues expect a whole lot more C# to be written in the years ahead with AI, not less.
Yes. And I think that's fair to say. I see a lot more code coming. I see us getting sharper and being able to leverage these tools that are literally, there's a reason why we call them co-pilots, right? It's because somebody else is the pilot, right? And so I'm looking forward to being able to say very quickly, I need this done. Cool. And now I move on with the creative thinking part, and not filling out the boilerplate, which is what I want to do anyways. So yeah. I think we've got some good years ahead of us.
Awesome. It's a good time to be a .NET developer.
Yeah.
Well, Dustin, thanks so much for coming on the Azure and DevOps podcast. I love the conversation, and I know the listeners did as well. So thank you so much.
Absolutely. Thanks for having me.
Oh, my pleasure. My pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.